Welcome to this presentation on probability distribution 1. For probability distribution 1, I'm going to discuss the questions on normal distribution, which is the short question that is going to come up in paper 1 SPM. For information, we have the probability distribution 2, which I'm going to discuss the longer questions, which is normally come up in SPM paper 2. First, I'm going to introduce to you the normal distribution. A normal distribution is a probability distribution of continuous random variables. The distribution is denoted by X is normally distributed. You have to put your mean and the variance. So mu is the mean of the normal distribution and sigma square is the variance of the normal distribution. A normal distribution with mean equal to 0 and the variance equal to 1 is called a standard normal distribution. So the standard normal distribution, you have to use the Z. This is normally distributed with mean 0 and the variance is 1. A normal random variable X is normally distributed with mean and sigma square, can be converted into a standard normal distribution. So standard normal distribution will be Z. You have to use these formulas to convert it. That is, your Z equal to X minus mu over sigma. Mu is the mean and the sigma is the standard deviation. Pay attention here. You have to know how to convert a normal random variable X into a standard normal random variable, that is your Z score, because the probability table given for normal distributions is the standard normal distributions. That is where the mean is 0 and the variance equal to 1. Next, I'm going to show you the standard normal distribution. Now we're going to discuss the standard normal distribution. The standard normal distribution is represented by the Z score and is normally distributed with mean 0 and the standard deviation is 1 and the variance is 1 as well. First, we look at the shape of this standard normal distribution is a bell shape, and the standard normal curve is symmetrical about the vertical axis through its mean, and the mean equal to 0. The total area under the normal curve, the total area equal to 1. So this implies that the whole area here under the curve equal to 1. Since the total area equal to 1 and the standard normal are symmetrical about the mean, so you can say that the probability, the standard score more than 0 should be equal to 0.5, half of 1. And the probability Z less than 0 is equal to 0.5 as well. So now you know that the area of the region bounded by X equal to A and X equal to B, here is X equal to A and X equal to B. This area here, this area that is between X equal to A and X equal to B is the probability Z more than A and less than B. You can find this probability using the probability table that is given in the exam. Now the last one, the mean, mode, and median of the standard normal curve have the same value that is equal to the mu, where the mean, mode, median equal to 0. Next, I'm going to show you how to find the probability using a standard normal distribution table. This table is given in your exam. Make sure you know how to find the probability from the table, because all the questions in the exam, you are required to find the probability using this table. Now I'm going to show you how to read the standard normal distribution table, which is the Z score here, that is normally distributed with mean 0 and standard deviation 1. So this is the only normal distribution table given in your exam. So you have to know how to read this table. This is the first step for you to master your normal distribution. This is because almost all the questions in the exam will involve the normal distribution table. So this is part of the table which is given your exam, you can see here this is the upper tail probability. So what it means by upper tail probability? So this table in the exam will only give you the probability on the right hand side. So when you see 1.5 here, the probability is 0.0668. So this implies that probability Z more than 1.5 equal to 0.0668. So what they're given is the upper tail probability. That is the area on the right hand side. If you want to find the probability Z less than 1.5. So remember, this standard normal distribution is symmetrical about 0. So you want to find less than 1.5. You are looking at the probability here. But from the table, you are given the probability at the right hand side, which is Z more than 1.5, 0.0668. So you want to find probability Z less than 1.5, you can use the total probability, which is 1, minus probability Z less than 1.5. This equal to 1 minus 0.0668. This is equal to 0.332. Next, I'm going to show you to find the probability of different kind of region using the table given. So first, I'm going to show you how to find the probability Z more than 1.63. So remember, the first step is to shade the region. So you are going to find the probability Z more than 1.63. So this is the upper tail probability. You can get it directly from the table. So you search for 1.63. So the probability here is 0.0516. So this is very simple. For part B now, you have to find the probability Z less than negative 1.63. So this involves negative number. You may see that your tables only show the positive number. So how to find this probability? So less than negative. So you know that in the middle is 0 here. Negative value will be somewhere around here. So you have to find this probability, that is the Z score less than negative 1.63. So remember, I told you this curve is a symmetrical curve. So this probability is the same as the probability that is same as probably Z more than 1.63. So this is the upper tail. You can get directly from the table. Your answer is again 0.0516. So part C now, I have to find the probability Z less than 1.72. So first you shade the area first. 1.72 will be somewhere around here. You want to find this probability. So you know that this probability is not given in the table, but you can find the probability here. That is, you can use the total probability minus the shaded region with the red color here. That is a probability Z more than 1.72. This is the upper tail probability, which is given the table. So you have 1.72. The probability is 0.0427. So this will give you answer 0.9573. So part D now, if I want to find the probability Z more than negative 1.72. So you know that negative number are not given in the table. First step, you still shade your region. Negative 1.72. So you need to find this area here. So because of the symmetrical nature, this shaded region is the same as the shaded region here. That is the same as probability Z less than 1.72. Remember, this equal to 1 minus probability Z more than 1.72. That is the same as this one. 1 minus 0.0427. This equal to 0.9573. Now we're going to a little bit harder. So let's say you want to find the probability Z is more than 0.52 and less than 0.93. So you want to find this probability here. So again, the first step is to shade the region. Both is a positive number, so you should know that you have 0.52 and you have 0.93. You want to find this area here. So again, you know that the probability given is the upper tail probability. That is a probability on the right hand side. So what you can do here is to use the probability Z more than 0.52 minus probability Z more than 0.93. So you can see here the probability Z more than 0.52 will be all the way here, the probability. If you minus out this probability, that is probability Z more than 0.93, you will get this area in between 0.52 and 0.93. So what is the probability Z more than 0.52? This is the upper tail probability. You can search for 0.52. So the probability is 0.3015 minus probability Z more than 0.93. Again, this is the upper tail probability, 0.93. This equal to 0.1762. Therefore, your answer equal to 0.1253. So how about this? You want to find the probability Z more than negative 0.4 and less than positive 0.61. So now the first step here is to shade the region. You have one negative number. So it's negative 0.4. Remember, your 0 is here. So negative number will be on the left. And you have one positive number, 0.61. Now you have to find this area between negative 0.4 and positive 0.61. So how to find this? This equal to the total probability 1 minus the probability here, that is probability Z more than 0.61 minus probability here, that is probability Z less than negative 0.4. This equal to 1 minus. This is the upper tail probability, more than 0.61. So you are searching for 0.61 here. So the probability is 0.2709. Now you need to find the probability Z less than negative 0.4. Remember I told you, because this curve is symmetrical, this is also equal to the probability Z more than 0.4. Because this is a negative number, you will never be able to find a negative number for your Z score. So you have to convert to the upper tail probability with the Z being a positive number. So this equal to 1 minus 0.2709 minus Z more than 0.4. So 0.4 will be here. That is 0.3446. This equal to 0.3845. I'm going to start with the first question on normal distribution. This is a very straightforward question. Find the value of Z if probability the Z more than small z equal to 0.0594. First, I need to introduce to you the standard normal distribution Z, which is normally distributed with mean 0 and standard deviation 1. So always remember, if you want to represent a normal distribution, you have to put like that, normally distributed, then you put the mean, and then you put your standard deviation squared. So this is a standard normal distribution. This distribution will look like this. The standard normal distribution is symmetrical about the mean. In this case, your mean is 0. And remember, the total probability equal to 1. This implies that the probability Z more than 0 equal to 0.5. That is half of the probability. And the probability here, that is the probability z less than 0 is also equal to 0.5. This is the probability that is given on your table. I'm going to show you the table now, which is given in your exam. This is a part of the table that is given in the exam. Can you see here? This is the upper tier probability of the normal distribution 0, 1. This is a standard normal distribution. You have to know how to read the table. So for this table here, they always give the upper tail, that is, they're going to give the probability on the right hand side here. So you can see if I want to find 1.2, the probability z-score more than 1.2, I'm going to search for 1.2 here. 1.20, the probability is 0.1151. So remember, the probability here is on the upper tail, that is on the right hand side. If you understand this, you can solve part A directly. Part A here, probability z more than z equal to 0.0594. So you know that probability z more than 0 is 0.5. So you can see here this value 0.0594 is lesser than 0.5. And you know that the probability z more than 0 is 0.5. So you should expect the shaded area will be smaller than this area here. So it'll be somewhere around here. This area equal to 0.0594. Now you're supposed to find this z value here. So now you're going to look at the probability. Remember, inside here, this portion here represents the probability. So now you're going to search for 0.0594. You can get it directly from the table because I told you this table will give you the probability on the right hand side. So now you search for 0.0594. You can see here this 0.0594. So this equal to 1.5. Then you search for here 6. So therefore your value for z equal to 1.56. So this is the answer for part A. Now for part B, we have to find the probability z lesser than z equal to 0.8577. The first step is always to shade the area first. So this is a standard normal distribution. You can see here this value is more than 0.5. So you should expect the value should be here because they are less than a z here. This area here represents 0.8577. You can't get 0.8577 from the table because your table only gives you the upper tail, that is this tail here, the tail on the right hand side. So you have to find the probability here, which is equal to 1 minus 0.8577. This equal to 0.1423. Now you know the probability on the upper tail. You can get it directly from the table. 0.1423 is somewhere around here. So we have to find the z-score. So this is 1.07. Therefore, your answer for z will be 1.07. So now you can see it's very important that you know how to shade the region and be able to read this table. So you will be guided step by step by the following questions. Then you will understand the normal distribution fully. The following diagram shows a standard normal distribution. So standard normal distribution is a z-score, normally distribution with 0 and standard deviation 1. So if probability z more than 0 less than k equal to 0.2054. So where is this probability? The probability is here. In between 0 and k, this probability equal to 0.2054. We have to find the probability z more than k. That is, we are required to find this probability here. So this is a very simple question and very direct. So you know that for probability, this is actually a very simple question. So it's not necessary for you to use the table. So remember, for a standard normal distributions, they are symmetrical about the mean, which is 0. The probability z more than 0 equal to 0.5. So if you understand this, you want to find the probability z more than k, you can use 0.5, that is the probability z score more than 0, minus the red shaded region, which is given in the exam. The probability is 0.2054. Therefore, your answer should be 0.2946. Now look at this example here. The following diagram shows a standard normal distribution table. This is a z that is normally distributed with 0 and standard deviation 1. So now, given that the probability z more than k, so this is the probability here, is given. That is 0.0329. For part A, we have to find the value of k. So now we have to bring up the table for the standard normal distribution. So this is part of the table for the standard normal distribution. So 0.0329, this is the upper tail probability. So you can search for 0.0329 directly from the table. Remember, this is probability. So you are going to search inside here. Inside here represent probability. So where is 0.0329? So you can see here, this is the probability, 0.0329. This is correspond to 1.84. So you know that from the table, the probability z more than 1.84 equal to 0.0329. So therefore, for part A, the answer for k equal to 1.84. So now we proceed to B. We have to find the probability z more than negative k and less than k. This implies that you have to find the probability z more than negative 1.84 and lesser than 1.84. First, we try to shade the region. K, this equal to 1.84. And you have negative 1.84 here. You have to find this region. So again, this is very simple because the probability here is given. That is, this probability z more than 1.84 is given the question. That is 0.0329. And this distribution is symmetrical, imply the probability here, that is the probability z less than negative 1.84 is also equal to 0.0329. So to find this probability here, you can use the total probability 1 minus the probability for z more than 1.84, that is 0.0329, minus the probability z less than negative 1.84, which is also 0.0329. This equal to 0.342. Look at this question here. X is a random variable with normal distribution with a mean of 5.2 and variance 1.44. So this is not the standard normal distribution. Remember, the standard normal distribution z is normally distributed with 0 and standard deviation 1. So now x is a normal distribution with the mean 5.2 and variance 1.44. If the variance is 1.44, the standard deviation is square root of variance, which equal to 1.2. So this equal to 1.2, the standard deviation square. So for part A, we have to find the z score if x equal to 6.7. So remember, to convert to z score, we have this relationship that is z equal to x minus mean over the standard deviation. So now we have to find the z-score given the x equal to 6.7, the mean is 5.2, and your standard deviation is 1.2. This will give you a z-score of 1.25. So part B now, we have to find the probability x more or equal to 5.2 less or equal to 6.7. Now we have to convert to the z-score because the table given is the standard normal distributions. It means 0 and standard deviation 1. How to convert it? We are using this relationship. Z-score equal to the x value minus mean over standard deviation. So now we have probability. We have z here. We are using the x value 5.2 minus the mean, which is 5.2, over the standard deviation 1.2, less or equal to 6.7 minus 5.2, that's the mean over the standard deviation. So this will give you an answer, z more or equal to 0, less or equal to 1.25. Now we have to bring up the table for the standard normal distribution. So we have to find the region that is the probability between 0 and 1.25. So remember the table given is the upper tail probability. We can find the probability here. That is the probability z more than 1.25. So from this table here, you have 1.25. The probability is 0.1056. So now how to find this probability? So we have to use a probability z more than 0. That is a half of the probability, 0.5, minus the probability z more than 1.25, which is 0.1056. This will give you an answer 0.3944. The mass of students in the school has normal distribution with mean 54 kg and the standard deviation 12 kg. So you have the mass of the student, which is x, is normally distributed. The mean is 54 kg. The standard deviation is 12. So you put 12 square. Find A, the mass of student which give a standard score of 0.5. So this is very simple if you know the relationship between the z-score and the x. That is z equal to x minus mean over the standard deviation. Given that your z-score now is 0.5, you have to find the value of x, which is the mass of the students, minus the mean is 54 over the standard deviation, which is 12. So 0.5 multiplied with 12 equal to x minus 54. So x equal to 54 plus 0.5 multiplied with 12, yes, 6. So the value for x is 60 kg. Now for part B, you have to find the percentage of students with mass greater than 48 kg. So to find the percentage, first you have to find the probability. That is, you have to find the probability of the mass, which is x, greater than 48 kg. Always remember you have to convert to a z-score so that you can read from the table. How to convert to a z-score? You use the original x value minus the mean. In this case will be 54 divided by the standard deviation, which is 12. So you have probability z more than negative 0.5. So now you're going to bring up your standard normal distribution table. So this is part of the standard normal distribution table. We have to find the probability where the z-score more than negative 0.5. So we can't find the z-score with a negative number here. What we have is the upper tail probability with all the z-score is a positive number. So what you can do here is to change to 1 minus probability z less than negative 0.5. So this part here is the probability z less than negative 0.5. This equal to 1 minus probability z more than 0.5. Remember I told you because of symmetrical nature, this probability z less than negative 0.5 is the same as probability z more than 0.5. So now you can find this probability in your table. This is 0.5, which the probability is 0.3085. So you have 1 minus 0.3085. This will give you a probability 0.6915. So this is the answer in probability. You need to find the percentage. So what you do is times 100. So you have 69.15% of the students with mass greater than 48 kg. Look at this question here. Given that X is normally distributed with mean 16.8 and variance 20.25, and probability X more than M equal to 0.6064, we have to find the value of M. So the first step here, we have to find the standard deviation. Given the variance is 20.25, so your standard deviation will be square root of 20.25, which is 4.5. Given that probability X more than M equal to 0.6064. So now you can see here X is not the standard normal distribution. So we have to convert to the standard score. How to convert? We have this relationship, Z, the standard score, equal to X minus the means over the standard deviation. So now convert to Z score, we have probability Z more than, the value X now is M, minus the mean will be 16.8, over the standard deviation, which is 4.5, equal to 0.6064. So now we already convert to the Z score. So what is the area that I'm looking at? So we have a sketch here. We have Z more than this value. Let's say this value equal to a small z is 0.6064. This is more than 0.5. So I should expect the Z value will be here. This shaded region here equal to 0.6064. Now, how to find this value Z here? And you should know this is actually a negative value. The Z score is a negative value. Now I'll bring up the table for the standard normal distributions. So this is part of the table for the standard normal distribution. That's our Z score. Normally distributed with mean 0 and standard deviation 1. Always remember the probability given is the upper tail probability. So now we have to find the probability here. This equal to 1 minus 0.6064, which is equal to 0.3936. So this implies that the probability Z less than this small z here equal to 0.3936. So but what we have here is the upper tail probability. So you may notice here the 0.3936 is inside the probability table here. So remember, to find the probability, you have to look inside here where this is the probability. So we are looking at 0.3936. So this is 0.3936. The Z score is 0.27. So now a lot of students make mistake here, that is they put the Z score as 0.27. So remember, I told you that the Z score should be negative. Why is it negative? Because for a standard normal distribution, the mean here will be 0. Therefore, our Z score on the left hand side will be a negative value. So now we should know that probability Z less than negative 0.27 is equal to 0.3936. Now you can proceed to find the value m, because we know that this value here, that is m minus 16.8 over 4.5 equal to negative 0.27. That's the z-score that we just found. So some students may ask why I can directly put this as the negative 0.27. So look at it carefully here. We know that the probability z less than negative 0.27 is 0.3936. So you imply that this is the value negative 0.27 here. The area here is 0.3936. So the area here should be 1 minus 0.3936, which is 0.6064. This implies that probability z more than negative 0.27 equal to 0.6064. So you can compare this with this whole equation here. So you can see that they are actually similar. That is, probability z more than this value equal to 0.6064. Therefore, I can put m minus 16.8 over 4.5 equal to negative 0.27. So what is the value of m? M minus 16.8 equal to negative 0.27 multiplied with 4.5. This equal to negative 1.215. Your m equal to negative 1.215 plus 16.8. Therefore, the value of m should be 15.585. So make sure that you understand this question, because this is the very common mistake by the students.